What's the difference between an array and an event? This was a question asked to me actually 5 years ago when I was at Microsoft, and this technology was just being developed. And the answer absolutely blew my mind. It totally changed the way in which I approached asynchronous programming. And I hope that you guys feel the same way after this presentation in this class. So events and arrays are both collections. I want you to start thinking about them in exactly the same way. Even though they have very different interfaces today in JavaScript. It doesn't have to be that way, and I don't think it will be that way for much longer. So why don't we just program these things the same way if they're both collections? Why do we program slurping data out of arrays differently than we would events? We should approach them the same way. How did we get this place? How did we get to thinking about these things so differently when I just showed you that we can think about them in a very similar way? Well, to answer that question, you've got to go all the way 20 years back, more than 20 years back, to 1994. It all comes from a little mistake that was made almost 20 years ago. Who's got this book or read this book? One guy back there. This was a popular book. It was a book. The idea was 20 years ago, you had a lot of software engineers, and they sort of got together and they said, well, people are solving the same problems again and again all through the industry, but they're solving it slightly differently. What we need is to sort of take these common patterns in software and put them in a book. And that's how we got the Design Patterns book from the gang of 4 authors there, those 4 authors. And that was a tremendously influential book. It was targeted at C++ developers and Smalltalk developers. But nowadays, this notion of design patterns is still popular in the Java community. It's probably less well known in the JavaScript community, but it was very influential, and it defined a lot of the patterns that we use today in computer science. Now, there was a sort of a picture in the back of this book. Don't worry, we're not teaching all this stuff today. I'm actually just going to focus on 2 of these things. They're actually showing how all these patterns were sort of interrelated. But today we're only going to focus on 2 of them. The iterator and observer pattern. So the iterator pattern is actually something that's coming in JavaScript 6. And we're going to talk a little bit about how that's going to work. Now, they did not think that these 2 patterns were related. They didn't even draw a line between them if I go back there. They don't even think that these 2 patterns are related. You see the observer way out there. But I'm going to suggest to you they are related. They're actually deeply related. And understanding their relationship is key to becoming an expert in asynchronous programming. So here's how an iterator works. It's very simple. You have a producer and a consumer. And the consumer requests information one at a time from the producer until one of 2 things happens. The producer says, I have no more information for you. Or the producer says, an error occurred. Does that make sense? So how this looks in JavaScript is in JavaScript 6, the next version of JavaScript, you're going to be able to walk up to any array and request what's called an iterator object. So think of this as a way of a function sort of returning multiple values. So an iterator object has a very simple interface. You can call next, and you'll get out this little object, which gives you the value that you requested, and also gives you a little Boolean indicating whether or not there are more values for you to get. So here I've got 1, but I see that we're not done, so I'm going to call next again. Now I have 2. Now I see we're still not done. So I'm going to call next again. 1 final time. 3, not done. Call next. Finally, I get a little message that says, you know what, we're done. So go back to that consumer-producer relationship. I'm the consumer in this case, and I'm just pulling values out of this producer, which is the iterator. I'm pulling values out until the producer says, I'm done. No more information for you. So the gang of 4 defined this pattern in the 80s. I think 80s, early 90s. And now it's actually just making its way into JavaScript. So it's a nice constant, it's a nice convention for having any data structure. I might have a set or a map or a vastly different data structure. Doesn't matter what it is. I can walk up to a data structure, and using this simple protocol, I can pull all the elements out of it sequentially one by one. Does that make sense? That's why they defined this particular design pattern. So that you could walk up to any particular data structure. You don't know anything about its internal representation, but you can still consume the elements inside. And this is actually the underlying technology that enables the new for of loop. There's a new loop coming in JavaScript 6 specifically for consuming this, so you don't have to write all this boilerplate code. You can write what just looks like a simple for loop. So map and filter and concat all can, in addition to being implemented over an array, can also be implemented over an iterator. Let's just think about that for a moment, right? I can write a map function which, given an iterator, returns another iterator. And every single time it pulls a value out, it applies that map function to the value and then returns the translated value. So you can apply a map and a filter and a concat all. Concat all would be a 2-dimensional iterator. You'd flatten it into a 1-dimensional iterator. All the operations I've shown you thus far are actually, at their root, probably, they can be expressed over iterators. Now I'm going to show you another pattern that the design pattern guys expressed. And this was all about UIs. They were concerned about how is it in the user interface, if you have a change to a model, how do you communicate to the view that something has changed? Or vice versa, how does a view communicate to the model that a user wants to do something? And they defined this pattern called the observer pattern. Now probably most people in this room are familiar with the observer pattern because it's something we in JavaScript use every day. Because it's just DOM events. So they defined a way that you could add a function to some data producer, and instead of the consumer pulling the data out one at a time, instead the producer pushes data at you, right? That's how an event works. You hand me a callback, and then when I want to send you information, I'm the producer, I push you information one item at a time. Does that make sense? So in one of these patterns, in the iterator pattern, the consumer is in control. The consumer is pulling values out. It decides when it gets the next value. But in the observer pattern, the producer is in control. The producer decides when you get the next value, because it calls your callback and pushes it at you. Does that make sense? Right? So it's really, these two patterns are about doing the same thing fundamentally. They're about a producer getting a consumer items one at a time. The only difference is who's in control. But the design patterns guys made a little mistake. So this shouldn't blow anybody's mind. This is just what happens, right? I move my mouse around and we get the results. They made a little mistake. They failed to see this connection, that at some deep level these things were both about the same thing. We're both about progressively sending information to a consumer. And they didn't see that the iterator and observer pattern were symmetrical. And so this is how you understand the observer pattern. If you already understand the iterator pattern, right? The observer pattern iterates you. That's kind of what's happening, right? The observer, the producer, is iterating you, right? So they missed this symmetry. And as a result, 20 years later, we think about asynchronous programming very differently than we probably should. There is a subtle difference between the iterator and the observer pattern as they outlined it in design patterns. Remember what I said about the iterator pattern. You can pull values out until one of two things happens. What are those two things? Can anybody tell me?
Error and array.
Error and it's done, right? No more data, or the producer throws. Like that means if I call next, they could throw, right? And that's how I would know that an error occurred. But with the observer pattern, they failed to add any of those, any well-defined way of the producer expressing to the consumer that A, there was no more data, and B, that an error occurred. Let's go back to our DOM event listener example, right? You pass one callback to this thing. The only thing that you can receive, the only message you can receive from the producer is, here's some more data. And why did they do that? Well, they were very focused on the event use case. They were very focused on solving for UI events. And the thing about UI events is there might always be another one, right? Because somebody could always click another mouse click. They could always move the mouse again. And so they weren't really thinking that, oh, you need this notion of completion, because they were very narrowly thinking about how to model events. But today, 20 years later in JavaScript, we deal with push streams that end all the time. Anybody ever work with a node stream, for example? Which is an I/O stream that you use in Node. Obviously, I/O streams can end, right? And so we need some well-defined way for a producer telling a consumer, I've got no more data for you. Right? So because we missed this standard way of these three semantics, there's no well-defined way of saying completion or error. Today on the web, we have a proliferation of different stream APIs. And all of them are slightly different. Some of them might have a way of indicating completion, but not an error. Some of them have no way of indicating completion or an error, or they have some ad hoc mechanism where I'll send you an object, but then if you check this property, et cetera, then you know it's done. We have all these different interfaces. Whereas if you look on iteration, where the consumer's in control, we have one interface. It's just standardized. Everybody uses it everywhere. This is a mistake. We should have one interface that we use for push streams in JavaScript. And that is something very much like, at least, the observable. So if you can have an iterable, so an example of an array is an iterable, which is something that you can ask for an iterator from, right? So if we go back, an array isn't an iterator. It's something that you can ask to give you an iterator. Well, the opposite of an iterable, something that you can ask to give you an iterator, is an observable. And the way I want you guys to think about an observable is that it's a collection that arrives over time. Does that make sense? A collection that arrives over time.
There's a question.
We got it.
Yeah.
Go ahead.
You want me to read it?
Yeah, go ahead.
How different are iterators from generators? So the question is, how different are iterators from generators? Would it be naive to say that iterators you can get from arrays via iterator by calling the iterator method, which we saw earlier? And that that iterator inherits from generators defined for an instance of array. So explaining that question will require me to sort of explain generators and what they mean in JavaScript. And frankly, that's a very rich and complicated topic that isn't tremendously relevant to this here, but I can answer that question, which is to say that it's fair to think of a generator as something which you can both pull information out of as well as push information into. And the iterator that you get out of an array is just about the pull side. So for those of you in the room who don't necessarily understand that, that's OK. You don't need to know that for this particular talk. But hopefully I've answered that question. So it's just for the iterator, when you get it out of an array, all you can do is pull. I mean, you could push information back in by passing a parameter to next, but the array is going to ignore that information. So generator is this object, this weird little object we'll talk about at some point in JavaScript, which is you can pull information out of, but also send information back into. Not particularly relevant, so I don't want you to think about it too hard.